All right, hello and welcome. We are now looking at the rational root theorem. So the rational root theorem is used so that we can find the factors of any polynomial. So if you think about a quadratic, y equals ax squared plus bx plus c, a polynomial is any size. So we're growing here. So we may look at something like y equals ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f. So it's getting very large, right? And in this case, we can tell some things by just looking at this. This equation up here, the quadratic, is raised to the power of 2. So it can only have up to 2 solutions. X plus some number m times x plus some number n. It can only have 2 solutions, whereas this one here can have up to 5. So this could be factored into x plus m times x plus n times x plus p times x plus q times x plus r. Up to 5 factors. And so we want to be able to find these factors, and we want to be able to find them easily without too much trouble. So that is what the rational root theorem teaches us, how to convert this form into this form. So from standard to factored form. So we're going to go ahead and look at that. So we have ourselves an equation. It could be written in this form. It could actually be written also in the form equals y. Either way, remember when you're trying to find your zeros, it really isn't too big of a deal. So we can just say 0 here and it's fine. So we can solve this equation. Not all equations are solvable this way. They have to have rational roots, but the rational root theorem states that we can have up to 3 rational roots for this, because the highest exponent is 3. This is a cubic. This cubic function has up to 3 rational roots. So we can find those. So if they exist, if these rational roots exist, rational meaning that they're not irrational, these would either be whole numbers or they can be written as the form of a fraction. In case we have p as our constant, q is our leading coefficient of the highest powered x. Okay? We can take p divided by q. Now these are factors of p divided by factors of q. So we want to list all of the factors of p, which p is 20, so that is 1, plus or minus 1, plus or minus 2, plus or minus 3 does not go into 20. 4 does though, 5 does, 6 does not because 3 didn't, 7 does not, 8 does not, 9 does not, 10 does, and 20. So those are all of the factors of 20. All of the factors of 3. Plus or minus 1, plus or minus 3. Since 3 is prime, there's only 1 and itself. So these are all the factors. So all of the possible combinations are 1 over 1, which is 1. So here's all of the combinations. Plus or minus 1, 1/3. Well, let's do all over 1. So plus or minus 1, plus or minus 2, plus or minus 4, 5, 10, 20, and then we get some fractions, 1/3, 1 over 3. So plus or minus 1 over 3, 2 over 3, 4 over 3, 5 over 3, 10 over 3, and 20 over 3. So those are all the possible combinations. So I'm going to leave those up, and we'll get rid of this other so that we can keep working. Still on the rational root theorem. Okay, so we've got a lot of different combinations to try, and that is actually kind of upsetting. The less numbers you get here, the better. But unfortunately, we've got a lot of choices. So we're just going to go down the line and test them out. So the first tested number will be 1. We'll just try 1 and see if we can get this equal to 0. If this, when we plug 1 in for x, equals 0, then we are set. So that would be a really nice thing. So 3 times 1 cubed plus 8 times 1 squared minus 3, 31 times 1 plus 20. So we're getting 1 cubed times 3 is 3, plus 1 squared times 8 is 8, minus 31 times 1 is 31, plus 20. And does that equal 0? That's the question we want to know. So 3 plus 8 is 11 minus 31 plus 20. 11 minus 31 is negative 21 plus 20. 20. 11 minus 31 is 20. Negative 20 plus 20 is 0. Yes, indeed, 0 does equal 0. We're happy there. So 1 is a solution. 1 is a solution. Now we want to check our solution. So we're claiming x equals 1 is a solution. So if that's the case, we should be able to long divide. But there is a shortcut to long division called synthetic division. So we're going to actually start with that. I will show long division later, but I think synthetic division works pretty nice. So we're going to stick with that. So we've got our 1 in the upper left corner, and then we've got our numbers, but not the x's. We're not going to write the x's down, just the number in front of x cubed, then the number in front of x squared, then the number in front of x, and then the number that doesn't have an x involved with it, which is 20. Okay? So in this synthetic division, we are going to take our first number and just bring it straight down. You don't do anything to it. Now we multiply it by 1, and we get 3. Add them together, you get 11. Multiply by 1, you get 11. Add them together, negative 20. Multiply it by 1, bring it here, add them together. If we get a 0 here, then yes, indeed, when x is 1, we get a 0. So when x is 1, y is 0. Okay, so once we've gotten to this point, we can claim something very interesting, that when you factored this piece out, which is actually x minus 1, you say, wait a second, I thought it was x equals 1. Well, that's true. If x minus 1 equals 0, you'd add 1 to both sides of the equal sign, and that would leave you with x equals 1. So x minus 1 is a factor of this function here. So x minus 1 is a function, is a factor. And if you factored it out of here, this 3 becomes 3x squared. It loses one of its cube, one of its exponents. It drops an exponent value. X squared also drops to 11. We're bringing the 11 over, but then it's just x. And then minus 31, sorry, minus 20, because we're using that number, minus 20, and it loses one of its x's. So we have 3x squared plus 11x minus 20. So now we can factor that. 3x squared plus 11x minus 20. So let's go ahead and write that down. 3x squared plus 11x minus 20. So what we've basically done so far, hopefully you've followed the steps that I've done so far to get P over Q and to get x equals 1 and to get this. But here's what's really happening. We have just factored this into x minus 1 times 3x squared plus 11x minus 20. This line and this line are equals. They mean the same thing. So now we have an x squared. We want to factor this into 2 more groups. So we can do that. So let's go ahead. We could keep using these, but you could use the AC method, and then we don't have to guess anymore. Once you get to a square, you can use the factor by AC method and factor by grouping. So here we go. We've got A times C, and we've got a B. So A is 3, C is negative 20. 3 times negative 20 equals negative 60. And B is 11. So what 2 numbers multiply to give me 60 that also add up to 11? Now remember, in this case, we could be getting fractions. And so if that's the case, we won't get a whole number and the AC method won't work. But we will be able to then cross these out. So this is a worthwhile method. So what 2 numbers to multiply to give us 60? Well, 1 times negative 60, and then also positive 1 times, a negative 1 times positive 60. So, because it's a negative 60. So there's 2 of them there, but then 2 times 30, we'll say 2 times negative 30. 3 times negative 20. 4 times negative 15. And that might be it. So actually I think it's negative 4 times positive 15. Because if you add those 2 together, you get 11. So negative 4 and 15. Negative 4 and 15. Negative 4 times 15 is negative 60. Negative 4 plus 15 is 11. So we have figured out our 2 special numbers, which is negative 4 and 15. These are not what x equals, though, unfortunately. This is the AC method of factoring. So if you don't remember that, you might want to go back and watch the factoring lessons. So watch the lessons on the quadratics, because I go through factor by AC method and by grouping. So, all right. We don't need that anymore because we've got it written down here, negative 4 and 15. So we're just looking at this piece here. And we have 3x squared plus 15x minus 4x minus 20. You know, wait a second, why did you do that? Well, notice we got a 15 and our negative 4. That was just to break the 11x up. We broke the 11x up. So 15x minus 4x is 11x. 15x minus 4x is 11x. So, what do these 2 have in common? Well, they both have a 3. 3 times 5 is 15, and 3 times 1 is 3. They both have an x. X times x is x squared. X times 1 is x. So they both have a 3x in common. And what do they have left inside? Once you pull the 3 out of 3, you have a 1 left. When you pull an x out of x squared, you get an x. And when you pull 3 out of 15, 3 times 5 is 15. And when you pull an x out, it's times 1. Well, those 1's are redundant, so we don't need to write them, and they are confusing. So we're just going to write x plus 5. X plus 5. 3x times x is 3x squared. 3x times 5 is 15x. So we have factored that right. What do these two have in common? Well, it looks like a negative sign. So a negative 4. X plus 5. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Look, x plus 5, x plus 5. They are the same. So what do these two terms have in common? They both have an x plus 5 in common. So we can pull x plus 5 out of the first term, and we're left with 3x. We can pull x plus 5 out of the second term, and we're left with negative 4. We just figured it out. It's 5, and then 3x minus 4. So 3x minus 4 equals 0. You would add 4 to both sides and then divide by 3. 4 thirds. Was 4 thirds an option? Yes, indeed. 4 thirds was one of them. So if we had tried to do synthetic division on 4 thirds, we would have gotten the right answer. If we subtract 5 from both sides, so a negative 5, yeah, would have worked. So there you go. And then 1 was the other. Remember, there should only be 3 solutions, and there are. So we can rewrite this entire equation as x minus 1 times x plus 5 times 3x minus 4 equals 0. And we have factored that. And that is quite the feat. So we factored a cubic. And that is pretty huge. That makes a big difference. So you might be asked to find the solutions. And when you are, you're going to set x minus 1 equal to 0, add 1 to both sides, and get x equals 1. That's what we did. X plus 5 equals 0. Subtract 5 from both sides. And x equals negative 5. And the last one, 3x minus 4 equals 0. Add 4 to both sides. 3x equals 4 divided by 3. X equals 4 thirds. X equals 4 thirds. All right, so I've got a few things that are in boxes. We should identify what they are, because sometimes you're asked to find one thing and not the other. So if you are asked to factor, these are the factors. If you're asked to factor in an assignment, this would be the answer. If you're asked to find the possible roots, this would be your answer. If you're asked to find the roots, then these would be our answer. X equals 1, x equals negative 5, and x equals 4 thirds. So you can see how there's different answers and different stopping points in the problem. If you're just asked to find the possible roots and that's it, you just do this and you'd be done. If you're asked to find the actual roots, you may have to do the factoring to get them. Okay? If you're asked to factor, you could just factor it and you don't have to worry about what the roots are. So just depending on what the assignment is asking you to do will change how much work you have to do and what steps you need to follow. So let's go ahead and do another one. Alright, so here we have x to the 4th plus 3x squared minus 40 equals 0. And let's go ahead and find the possible rational roots the possible rational roots. So this equation is actually looking kind of funny to me. So I might want to rewrite it as x to the fourth plus 0x cubed. There's no x cubed up there, so I can input 1. Plus 3x squared plus 0x, there's no x, minus 40 equals 0. So I could do that. It might not be necessary in this step, but it oftentimes helps me to see what the equation really looks like in standard form. Ax to the fourth plus bx cubed plus cx squared plus dx plus e. So this is a quartic. Quartic means 4 exponent of 4. So the highest exponent is 4. It's not how many terms you have. It's what the highest exponent of x is. And so that's why it's called a quartic. Cubic would be to the third power, quadratic to the second power, and then linear. If it's to the first power, we know about lines already. So we are going to find the possible rational roots. So the possible rational roots are when you take p divided by q. And so we're going to say p is negative 40 and q is 1. So this is actually really nice. So remember that's really, we want to find all of the possibles. So all the possibles of 40 are plus or minus 1. These are factors of 40, plus or minus 2. 3 does not go into 40. 4 does though, plus or minus 4. Plus or minus 5. Plus or minus 6 does not work because 6 is a factor with 3 in it. So 3 didn't work, so 6 won't. 7. 7 times 5 is 35, and then the next is 42, so 7 doesn't work. 8. 8 might work, so 8 times 5 is 40, so 8 does work. 9 does not work because it's got a 3 in it. 10, that definitely works, plus or minus 10. You can actually figure out all the rest of them. 2 times what equals 40, and that's 20. 4 times what equals 40, and that's 10. We already did that one. 5 times 8 is 40. 10 times 4, 2 times 20, so plus or minus 20. And then 1 times 40, so plus or minus 40. And that's all over all the factors of 1. So that's plus or minus 1. So that's pretty nice. Well, when you divide anything by 1, you get that anything back. So this actually is our solution set. And that's pretty awesome. So this is our solution set. Okay. So if you were asked to find just the possible rational roots, this would be our answer. I'm going to write it down a little lower because I want some room. Now I want to find out if any of these possible rational roots are solutions. Let's see here. I'm going to test 1. It worked for us before. I don't know if it'll work again. 1 to the 4th plus, we really don't need the plus zeros, so I'm just going to use the top equation. So plus 3 times 1 squared minus 40. Save us a little bit of time here. 1 plus 3 minus 40. So 1 plus 3 is 4, minus 40 is not 0. That is negative 36. So we know that the positive value doesn't work. We need to still check the negative value. So let's go ahead and try that. Just because it doesn't work for the positive doesn't mean it won't work for the negative. So let's see here. Negative 1 to the 4th plus 3 times negative 1 squared minus 40. So we still get 1 plus 3 minus 40, because the negative 1 to the 4th is 1, and negative 1 squared is 1, so 1 times 3 is 3. So there we go, and we get negative 36 again. So that's fun. All right, so 1 and negative 1, we can actually cross them out. We don't want to erase them because this is a solution set. So oftentimes you're asked to find all of the possible and what they are. So don't erase them, but you can put a line through them just to identify you've tested them and it's not one of the solution sets. So let's try 2. 2 to the 4th plus 3 times 2 squared minus 40. This is more likely. 2 times 2 is 4 times 2 is 8 times 2 is 16 plus 2 squared is 4 times 3 is 12 minus 40. This is getting closer. So 16 plus 12 is 28 minus 40 is negative 12. So it's getting closer to 0 with 2. If we plug negative 2 in, a negative 2 to the 4th is 16. Negative 2 squared times 3 is 12. Minus 40 gets us negative 12 as well. So it didn't work. So both positive and negative 2 fail. Let's move this. I keep using it. I might as well have it over here. Okay. Okay. 4. 4 to the 4th plus 3 times 4 squared minus 40. This seems really way too big. 4 to the 4th. 4 times 4 is 16 times 16. So what I did is 4 times 4 times 4 times 4. 4 times 4 is 16. 4 times 4 is 16. 16 times 16 is what I'm trying to figure out now. So 16 times 16, 36, and then 6 plus 3 is 9, 6 and a 1, 6, 5 carry the 1, and we get 256. That's pretty huge. That's probably going to be a problem. So 256 plus 4 squared is 16 times 3, so 16 times 3, 18 carry the 1, 48 minus 40. So I think we can say with very strong surety that none of these numbers are going to work because the negative 4 to the 4th is 256 and negative 4 squared times 3 is 48. So it's still going to be way too big of a number. And then 5 is just growing, so it's getting bigger and bigger and bigger. So we know that none of these work. And we don't have to test them all. We're able to stop here. And so you say, wait, is there no solution? And the answer is yes, there is a way to factor this. But the formula for factoring a quartic is a couple pages long. And we're not going to do that in this class, plain and simply. So if you can't factor it using this, then you are done. You're done. So you would say, this is how you would say it. If it asked you for the rational roots, you'd say no rational roots. Done. There are no rational roots to this function. So there you go. That is another problem down. Let's do one that actually has rational roots. Here we've got x to the 4th minus 10x squared plus 9 equals 0. Okay, so we're going to do the same. We've got our p is 9 and our q is 1. So here we're going to have p over q. We're going to figure these out. So this becomes plus or minus 1 plus or minus 3 plus or minus 3 again, which we don't want to write it twice, and then plus or minus 9 over plus or minus 1. So this is another nice one where we don't have too many options. So there we go. Those are all of our possible solutions. Let's see here. We're going to have, we're going to plug in 1. So we got 1 to the 4th minus 10 times 1 squared plus 9. we want to know, does that equal 0? So 1 to the fourth is 1 minus 10 plus 9. Well, 1 minus 10 is negative 9 plus 9 is 0. Yes, indeed. So 1 worked. So we actually want to do some synthetic division on this problem. So we're going to do our 1 and 1. This is where we need to rewrite this as x to the fourth plus 0x cubed minus 10x squared plus 0x plus 9. Now when we write our synthetic division, we can see it's a 1, a 0, a negative 10, a 0, and a 9. We can't miss those. If we miss those in our synthetic division, it will not work. So again, synthetic division, you always bring the first number down. That's a 1. Okay? 1 times 1 is 1, plus 0 is 1, times 1 is 1, plus negative 10 is negative 9, times 1 is negative 9, plus 0 is negative 9, times 1 is negative 9, plus 9 is 0. It worked out, and we get our new equation. X cubed, that's 1x cubed, plus 1x squared minus 9x minus 9. So everything lost 1 power, and that's what we got so far. So we want to write that down. So this is x equals 1. X equals 1 worked. X equals 1 worked, so that's x minus 1. Because again, when you set that equal to 0, you add 1 to both sides. So that's where the 1 came from. That worked. And we were left over with x cubed plus x squared minus 9x minus 9. So you don't just cross the 1 out at this point. Just because it worked once doesn't mean it might not work twice. So we're going to test it again. So we can test 1 again on x cubed plus x squared minus 9x minus 9. So 1x cubed, 1x squared, negative 9x, and negative 9. So we can do our synthetic division to see if it works. We're going to bring the 1 down. 1 times 1 is 1, plus 1 is 2, times 1 is 2, times plus negative 9 is negative 7, times 1 is negative 7, plus negative 9 is negative 16. That is not 0. So 1 now, we know 1 only worked once. So the positive is done. Now let's test the negative. So here we're going to bring down the 1. Always bring down the first number. 1 times negative 1 is negative 1. Plus 1 is 0 times negative 1 is still 0. Plus negative 9 is negative 9. Times negative 1 is positive 9. Negative 9 times negative 1 is positive 9. Positive 9 minus 9 is 0. That worked out. 1, 0, negative 9. So that's 1x squared plus 0x minus 9. And negative 1 worked. Well, negative 1, that's x equals negative 1. So that must be x plus 1. X plus 1, if you subtract 1 from both sides, you get x equals negative 1. So the negative 1 worked. So positive 1 and negative 1. And then we have x squared minus 9. All right, so x squared minus 9 is factorable. You can do the synthetic division. 3 and negative 3 are the two numbers, because you can factor this into its conjugate pairs. So you guys have been using conjugate pairs a lot lately, so hopefully this just comes naturally. X minus 3, x plus 3. X times x is x squared, negative 3 times 3 is negative 9, and we know the two middle terms cancel out when you have conjugate pairs. So it's that simple. Done. We have our possible solutions, and we can state our real solutions, which is x equals 1, x equals negative 1, x equals 3, and x equals negative 3. If we add 1 to both sides of x minus 1 equals 0, we get x equals 1. If we subtracted 1 from both sides of x plus 1 equals 0, we get negative 1. If we added 3 to both sides of x minus 3 equals 0, we get positive 3. If we subtracted 3 from both sides of x plus 3 equals 0, you get x equals negative 3. So these are our solutions. This is the factors, and these are the possible solutions, which ended up working out really nice. Positive and negative 1, positive and negative 3. The 9 would not have worked if we had tried it. So there you go. Hopefully that helps with the rational root theorem. It's a lot of information. You might watch it a couple of times and then try out some of the problems for the week. All right, thank you so much. Have a wonderful day.